Okay, we're back again. This is Jason. Call myself Rashawn. And in this hands-on right here, we're going to use the AWS Pricing Calculator. Let's say that we are a company trying to move and migrate into the cloud, and we just want a bit of an estimate of how much money we'll be spending every month or every year to maintain services on AWS. So right here, we have a prompt. And we want to do a few things here. So the top right there, we're going to make some EC2 instances. We're going to have 5 application servers in production, 3 in the stage phase, and 2 in the development/testing phase. As you can see there, the production will have all of the resources we'll need, whereas the stage and development will be we won't need to have as much with those two as the production. And at the bottom there, we're going to use Oracle databases in the same format using RDS. As you can see there, the production databases will have more vCPUs and more memory than the others. So we're going to follow this template as we go on here. I might stick it on the screen just for simplicity, but first, obviously, you're going to go into the AWS Pricing Calculator at calculator.aws/#/ We're going to click on create estimate, and we're going to start using this. So we will need EC2 instances for our production and also for a stage/development/testing. So we will search here in the find service, and we find Amazon EC2. We're going to configure that. We're going to enter a description. So we'll call it EC2 prod. This will be the customer facing EC2 instance, which will have most of the vCPUs and most of the power associated with it. So you choose a region. We're going to have the same region for all of this. So we're going to keep it at Ohio for now. Tenancy, shared instances, operating system will be Linux. Workloads, keep that at constant usage. As we see in the picture here, for production we need 5 application services. So we're going to throw in 5 right here. And down to the EC2 instances, as it says over here, we need 8 vCPUs and 16 gigabytes of RAM. These are what these numbers represent here. So we will check 8 vCPUs and 16 gigabytes of RAM. You can also check for instance family if you want, which you probably shouldn't. And if network performance is a prerequisite, you can also throw that in as well. So right here, we see top of the list, we have 8 vCPUs, 32 gigs of memory. The network performance, though, is at 5 gigabits. Now, we only need 16, right? It may make more sense to go with 10 gigabits of memory, or excuse me, 10 gigabits of network speed. I'm not too sure what I said before. So we are going to go with this. It is only 0.04 cents more per hour. Of course, like I said, if we value memory, then we can go with this one. But if we value more network performance, we could go with this one, especially when we only need 16 gigabytes of RAM. So we go down here, we will keep with the compute savings plan. Obviously, you can go to EC2 savings plan as well if you would want. We'll have a reservation term of 3 years, and of course, the larger term that you pick, the more savings you will get. As you can see here, if you reserve for 1 year, you'll pay $146 a month for this section. But if you save for 3 years, or lock it in for 3 years, it'll only be $95 a month. And of course, we can pick partial upfront, no upfront or all upfront, then there is no paying per month. But we're going to stick with no upfront. I think we're going to stick with compute savings plan for the entire time here. And the only other thing we'll need to take a look at is elastic block storage. We will switch this to GP2. And as we see here, for block storage, we will need 2 terabytes in total of block storage. However, we have 5 application servers, which means if you take this number, divide it by 2 terabytes in gigabytes, then we'll knock that down to 400 gigabytes for each of the 5 instances. So that's all we'll need. If you want to take a look at any one of these, then you can, but we're going into the cloud, so we don't need to transfer anything. We'll save and add service, and we will do the same for the EC2 stage and dev/test. We're going to combine them both here. So we will give this a description just so we know what it is for. EC2 dev/test. And we're going to do the same thing. We're not going to change anything else with this because, when you take a look at this, these are all related. So we're not going to change the tenancy or the operating system. These two will be built and evolve into the production. So of course they'll have to stay very consistent here. For the number of instances here, in fact, we're going to put stage dev test right here, actually. Since they need the same vCPUs and the same number of gigabytes of RAM, we're just going to combine these. So 3 plus 2 is 5. So we're going to have 5 instances here. We're going to use 3 as stage individually and 2 as development/testing. So take a look here. We want 4 vCPUs and 8 gigabytes of RAM. And we take a look. We have the same type of thing here. T4G large will give us 4 CPUs but 16 gigs of memory, whereas C6G large, extra large rather, will give us 4 CPUs and 8 gigabits of memory, but more network performance. And since the difference here is negligible, we're going to go with the 8 gigs of memory here, since 16 might be overkill for what we're doing, especially in a production environment. We're going to keep the compute savings plan over here, and for the block storage, back to GP2. And again, we're going to combine these both. So since we have 5 application servers, we'll combine the block storage here. These are 1.5 terabytes. Since we have 5 applications services, we'll throw in 300 gigabytes here, because again, 300 gigabytes times 5 application servers, 3 plus 2, will give us our 1.5 terabytes combined of block storage. That's where the logic of that comes in. Next up, we're going to add some load balancers. So we'll type in the find service here with ELB, Elastic Load Balancing. So we'll type ELB in here just to know what it is. It'll be an application load balancer, of course, as we are using EC2 instances. And we need a load balancer for each one of these categories right here. So we will take 3, and these will have to be determined right here. So again, this is for EC2. We're going to say that we are going to push about 2 gigabytes per hour on average of data. And for average number of requests per second per application load balancer, we will give that 100. Same with rule evaluations, and we will add that to the service. As you can see, the cost increases as you put more things and add more services in. So we have our 3 load balancers. Next, we will look for elastic file storage here for our network file system, or elastic file system for our network file system. We'll configure that and call that EFS, or NFS. We'll call it NFS actually. And for this, we see our NFS storage across all three of these here. So 1 terabyte plus 500 gigs plus 250 gigs will be 1.75 terabytes a month, or 1750 gigabytes a month. Everything else can stay the same, and we will add that service. And next up at the bottom here, we will need to add some Oracle databases for our production environment, our stage, and our development, or stage deployment, and also our development/testing here. So we will, for those Oracle databases, we will use Amazon RDS Custom for Oracle and configure that. So this will be RDS for our production environment. We will want 2 RDS instances here, and we will need 38 vCPUs and 156 gigabytes of RAM. So let us take a look here and see what will give us that amount. And these, of course, are listed by cost. So at least each category is separated by cost here. So a little bit of research we may have to do here. So what we see here, none of these are going to be exact. So even though you only need 40 vCPUs, it goes by 8, 16, 32, 48, 64. So we may have to go a little bit over that. Right here we see DB M5X12 large will give us 48 vCPUs and 192 gigabytes of RAM at $7,200. Let's take a look at what we have down here. This is M6i 12X large for the same specs, but since it's a tier up, we would expect the cost to go up. And it does not actually. It does not. It goes down to $6,000. And if we look a bit further here, we go with R5. $9,800. It's got a lot more memory, I suppose. Take a look at one more. If there's a 48,192 here, and there isn't besides this one, but that'll be $8,000. So let's take a look at this. This would be $7,200. And going back to this one, that would be $6,000. Now, obviously, there may be a bit of a caveat as to why this is $1,200 cheaper. It may have to do with something else, but that will have to be researched, obviously. But for now, for this demonstration, we're going to pick the cheaper one. Obviously, you would research those both just to get a comparison. But we will go with this right here, since it gives us our vCPUs that we need and the memory. And for the storage, as we see here, we have 2 instances. We want 3 terabytes, so we're going to split 1,500 gigabytes among both instances. And for backup storage, we'll do the full 3 gigabytes, or 3 terabytes rather, and save and go. We'll want RDS for dev and test as well. Well, for our stage first, we'll do 3 of these. So for our stage first, because we've got different amounts of vCPUs and RAM for both of these, so we'll do this for our stage. So RDS stage. 2 instances. Now we want to take a look at what we can get for 16 vCPUs and 64 gigabytes of RAM. At first we take a look at this. This is $2,400. Let's take a look if we can see anything that is cheaper for 16 vCPUs and 64 gigabytes of RAM. And we have the M6i 4X large, which is slightly less expensive. However, just for this, we're going to go back with M5 X4 large. And for this, again, we'll also need 3 terabytes of storage. So we'll do the same thing here. 1,500 gigabytes times 2 instances will make that 3 terabytes. And we'll also have some backup storage in case something goes wrong. And we'll add that to the service. You got the gist of it by now. We will go to RDS again for Oracle, and we will fill out the development/testing section of this. So 2 instances, as we see right here, we want 2. This time we want 8 vCPUs and 30 gigabytes of RAM. And as we see here, DB M5 2X large is the one for it. You could also go with M6i 2X large, but again, research the difference between both of those. We'll go with this. And this time we'll want 1 terabyte of storage, so it'll be 500 gigs for each instance, and backing it up with a terabyte. And we'll add that storage as well. So now we have everything, and we're going to click on View Summary down here. And we still need one more thing to do, which is to add a service. Actually, add support, excuse me. And we'll put support in there, and now it'll ask you a couple of questions here, generic questions to show you which support plan you may want on the technical support levels. 3 basic questions here. You've got to pick what you may want. Of course, if you may need support on demand, multiple AWS support associates can call or email me 24/7 is probably what you would want. Not just one associate. And it may be more urgent of an issue at times than to just go on AWS support and wait for someone to get to you. So we'll pick this. And for technical support response times, this is a bit more in-depth here, more specific. What the SLA is that you want. And we're going to pick 15 minutes or less for this one. Once we put that in, the only one or the only support plan that is fitting for our company is the enterprise support plan. So we're going to pick that. One more question says, how much does your enterprise spend on average for AWS services each month? And since we are not in the cloud yet, that would be don't have enterprise support, even though we're going to get enterprise support at some point. So we're going to add that to the estimates. And right now, our company is going to pay $330,000 a year, or $27,000 a month, basically, for these AWS services prospectively. So we can do some more data analysis on that as well. We can press export and we can download a CSV, and we can open that CSV and bring it over here. Let me just change the colors here. I wish more people would do this, honestly. And as we can see here, the services that we want are right here. We see we're not putting in any upfront cost. This is how much it would cost monthly. Let us format cells here, making this into currency, since that's what we're dealing with here. Same thing with this. So currency, see the region here, US East Ohio. It's the name of the CSV right here, and just a bit of a summary of what we're going to have, or what we have decided to get. And let us say that you're going to present this to your bosses, your managers, when it comes to trying to get onto AWS. You got to be as accurate as possible, have a breakdown of the cash that your company is going to spend. So we're going to have the PowerPoint and documentation as well. I'm going to throw my name into it just to be in this position. And let's say that you are the, let's be a bit more fancy here actually, the Chief Cloud Architect. And these two over here, these two graphs, the monthly cost and the total cost for the year, these bar charts, or these pie charts, are going to show what services are going to be paid for, the breakdown of for the month. So we're going to edit data right here. Again, don't worry, the PowerPoint is going to be in the GitHub documentation. And we see the services right here, which we are going to copy and paste into here. And these will be the dollar amounts per month for each of those services. As we can see here, they both match. And as we can see here, they now reflect, obviously, the AWS support does take up a huge chunk of that. If you would want to remove that to see the other pieces of pie here and have a better idea of that, you can do that as well. And we're just going to take or see how much total cash that will cost for the month. It's $27,469. So we'll put that manually onto the graph here. And if you already are in America, then you can put the $sign in front. So that is the glaring number that the company will have to pay each month. And same thing for the total cost. So just click anywhere on the graph here, up to chart design, edit data. We're going to do the same thing for this. Actually, we will put the services in first, of course, and paste that there. And the amount of cost for each of them will go here. We can close that, get the grand total of this, and we can copy this number, and hopefully we can throw it into here. Although we lose or we gain the formatting, I suppose. If you do Control-Shift-V and do that. And so this will be the glaring number per year that the company will have to pay to manage the AWS services. Hope that gave you some good ideas. Again, this is Jason, call myself Rashawn, and we used the AWS Pricing Calculator to show the idea of what will happen for a company as they inquire about getting into the AWS cloud. We'll see you next time.